You're just about halfway through your first student trip. Think you'll stick with railroading?
Oh, it's fine so far. But a couple of my buddies say there's no future in it. You know, you hear so much about railroads not being around much longer, that they can't meet competition, they don't keep up with the times, you know.
Yeah, I've heard all that. But long after I'm Pocatello Night Yardmaster in the Happy Hunting Ground, and you're a fire-eyed officer who has fricasseed supervisor for lunch, this outfit will still be here. I'll tell you why.
Those rails, there are 790,000 miles of iron road that lace this world of ours. And the wheels that roll on them are the basis of the most efficient means man has yet invented for fast mass movement of the things he makes and the stuff he makes them from. Some competitors may claim to be faster. Some may tell us they're cheaper. But there's a joker. They are all raising the cost of transportation because we taxpayers are footing a lot of the bills for their radar and drawbridges and locks and one of the biggest items of all, heavy-duty superhighways with traffic enforcement and control systems. But railroads build and repair their own roads and safety devices and pay high taxes on them besides. Even at that, we could haul most things for less than the other fellas if we were allowed to really compete.
Well, if the railroads aren't allowed to compete with airports, waterways, and superhighways that they help pay for, then what's the future?
The future's going to be all right. One of these days, we will be allowed to compete. It's because this country's going to wake up to the fact that it can't get along without healthy railroads. Let's take another look at that system map.
From this 3 million square miles of land, we get more than enough food for 180 million Americans and nearly every raw material for making things. We have the richest natural resources endowment of any people. It's all spread out. Every state mines, harvests, or manufactures something that every other state needs. Las Vegas, for instance, is a city that has to import nearly everything it uses, including poker chips. Nevertheless, from the Vegas area, not only a great deal of raw materials, but also considerable finished products are shipped out. 217,000 miles of railroad really unite the states. They help make us the biggest nation of consumers with the world's highest living standard by smoothing out our economic geography. For example, from a Wyoming iron mine, we hauled the ore that went to a Utah mill to make the steel that we hauled to a California factory to make, among other things, the bathtub that we hauled back here for a new housing project. Because of good transportation, an old sea dog of 3 years doesn't have to live across the street from a factory that is down the road from a steel mill that is next door to an iron mine just to do a little tugboating. Now here we are, Union Pacific, the strategic middle route, operating around 9,600 miles of road. We serve some of the best neighborhoods in the country. At Council Bluffs, we tap Chicago in the east. 7 railroads funnel traffic to us here. Once across the broad Missouri, we leave Omaha to the headquarters, folks, and head for the wide, wide west. At Kansas City, which calls itself the Heart of America City, we have extensive yard and industrial facilities along the banks of the Kaw and the Missouri. We interchange here with 11 other lines for more eastern and much southern traffic moving through this and the St. Louis gateways. Through these gateways, we can offer expedited service between eastern and western producers and markets, and most western sources of raw materials. Wheat. We switch hundreds of elevators in the great grain-producing states of the West. Lumber, biggest industry in the Northwest. Forest products make up around 12% of our total tonnage. Out of Cascade, Idaho, we haul in trainload lots rough lumber and logs down the Idaho Northern Branch to a sawmill at Emmett. And out of the Iron Mountain district of Utah, what do we carry? Iron ore, enough lately to make around 9 trains a week. Beef steak and shoe leather on the hook, rolled from nearly everywhere on the system. Sheep and hogs, too, are specific about Union Pacific. With the former Spokane International trackage in the family now, we've got a Canadian gateway. At Eastport, way up in the Idaho Panhandle, we interchange directly with Canadian Pacific. Here, car numbers and contents are subject to check against customs documents. We serve the West's most important ports: Los Angeles, Long Beach, Portland, Vancouver, Puget Sound and Grays Harbor ports. At Seattle, we have what amounts to another Canadian interchange. Several times a week, we send cars over salt water to British Columbia and to Alaska, too. Portland is 90 miles from the sea, but it handles more dry cargo than any other port on the coast. One of our hauls is lead and zinc ore filled from Terminal 4 to an Idaho smelter. Los Angeles, land of oil wells, palm trees, and movie queens, also has a harbor that is the West's busiest. Ships of 31 flags call here and at neighboring Long Beach. UP switchers are familiar sights at dockside. A reminder that a port's effectiveness is directly related to the means of moving cargo to and from its piers and wharves.
That's UP country.
Yeah, but since that map was drawn, there have been some new breeds of cat in the hauling business.
Competition, including other railroads. And just how do we compete? Besides low cost, a shipper wants speed and dependability. An example, railroad's a pipeline between a refrigerator factory and an appliance store. Now, money and space needn't be tied up in a year's supply of refrigerators when they can come a carload at a time as needed.
418 to Caboose, over.
Caboose, over.
What track do you want to set these 2 cars out on?
Set them out on track 2. Over.
Okay, X-ray 418 east, clear.
Now, where was that? Oh, yes. Railroads connect the factory to the store. And that helps keep prices down and prosperity up. Because with good transportation, stocks can be geared to sales. That releases capital and money flows. But when new merchandise is needed, it's needed quick, and it's got to come in good shape.
So the shipper's going to use whoever gives him the all-around best deal.
Right. Now, with rates regulated by the government, Union Pacific competes with other lines and other carriers by giving our customers speed, safety, dependability. We don't take a backseat to anybody when it comes to the tools we have and the ways we use them to give the best freight service.
What about equipment? Say railroad to a man, and the first thing he thinks of is locomotive. We've got them, around 1,300. Our freight units total better than 2 million horsepower. Figuring your average 5,000-ton, 100-car train, there's enough power to roll 214 drag, manifest, and symbol trains. If they all were drawn up, pilot to caboose, on the main line at once, and the engineer on the lead unit was at Tower A at Cheyenne, the flagman would just about be at the east switch at Wamsutter, 214 miles west. Railroad men around the world agree that the diesel-electric locomotive is a flexible, dependable, if expensive, piece of equipment. It is a standard item of motive power in this country. But that doesn't mean we're not always looking for something better. Uncle Pete has always been a leader in motive power development. Never been afraid to try something new when it seemed it might meet our needs. We pioneered the oil-burning gas turbine locomotive, developed it into a successful hauler. We also proved that a gas turbine fired by coal could be operated. In the great freight race, we've turned now to the high-energy locomotive. Diesels with 5,000 and more horsepower per unit are giving us the on-time, high-capacity performance you need to keep ahead in this business. Our diesel units, which range from 1,500 to 5,500 horsepower, are used much like building blocks, one or several according to the needs of the train. Now, you might say a locomotive is the most important part of a train, because a train sitting out somewhere with a dead engine isn't much of a train. A bad order engine is a real money loser for the company. And if you stop to figure, a money loser for you and me, because that stalled train is making some customers unhappy. And when that happens, we start losing business and jobs. The best insurance against undependable motive power is big shops full of the right tools and men who know how to use them. We got them. The shops at Salt Lake and Omaha are examples of how we make high maintenance standards meaningful. They're equipped and trained there to handle anything from a brake shoe renewal to a complete overhaul. Using production line techniques, some 500 cylinder heads a month can be reconditioned. One operation is that of grinding out the low spots in the valve seats. Also, in a month's time, 700 to 1,000 injectors, vital to diesel performance, are inspected and overhauled. Before they go back in an engine, their output must be within 5 cc's of a specified amount and must match the other injectors for that engine within 5 cc's. Although our maintenance standards are high, we make sure the things we buy are good to start with. For instance, to see how much they'll bend under a certain load, freight car crossbars are put to slow, steady torture in a tensile testing machine by the thoroughgoing men of our Research and Standards Engineer Department. Another of their responsibilities is the prevention of diesel engine breakdown by testing lubricating oil. The basic test is of viscosity, the liquid's rate of flow. It's done with a viscometer. If the sample flows too fast when the tube is in the 100-degree bath, it probably has been diluted with diesel fuel from faulty injectors. While a railroad deals with 5,000-ton trains, it also works with bits that tip the scale at maybe a billionth of an ounce. The super powerful electron microscope is an instrument that enlarges specimens in the proportion of making a 6-foot man look 16 miles tall. Among other things, it allows a study of how well the oil holds up after long use. A sample that shows up on the fluorescent screen as large black particles is oil that is becoming contaminated. Whether it's on the real Union Pacific or the scale model that we show at industrial fairs and exhibits, the boxcar is the workhorse of the railroad. We have nearly 25,000 general service boxcars, more than all our other types combined. But with our customers needing faster and safer service, we're providing more specialized and high-capacity cars, matter of competition. Some of the most interesting of these special cars, from the point of appearance and business they've generated, are the 89-foot multi-level cars for moving new automobiles. By using easily set ramps, each car can be quickly loaded and unloaded. With these 12 to 15 capacity cars, we can offer savings over highway haulage. This is an example of how investing earnings in new equipment pays off in more business for the company and more employment for railroaders. The highway transporters still get a share of the haul from unloading points such as ours at Denver to the dealers. Speaking of multi-levels, we developed these 3-deck stock cars so that we could move hogs more economically from the Middle West to coast points. By hauling more per car, we cut costs. In addition, the shipper saves time in spotting, loading, and unloading. Important to the shipper also is care and comfort of the animals. They still have plenty of headroom, and, as in all our stock cars, the decks are covered with sand and straw to ensure arrival in good condition. Most of our special cars are adaptations or refinements to standard cars. Take a general service flat car, add bulkheads built solid with the ends, and you combine the easy side-loading features of a flat with the end-holding qualities of a gondola. Acquiring these cars originally to carry slippery, fragile plasterboard out of Nevada, we've found other shippers who like them. The cantilever bulkheads are designed to take million-pound impacts, such as from the shifting forces that can come about with slack action in a moving train. Traffic men at an Oregon aluminum plant like the bulkhead flat car for moving ingots and other shapes. Heavily banded and end-stopped, the 13,000-pound ingots move securely. Like plasterboard, a commodity that is also hard to hang on to, is finished lumber. Another of our Oregon customers, a huge sawmill and wood products plant, finds the merits of the bulkhead flat car desirable for its purposes. Packaging #1 grade lumber protects it from the weather. Moving it on bulkhead flat cars ensures freedom from impact damage in transit. Recognition of the shipper's needs and the development of special equipment to accommodate him is typical of the revolution in railroading we're seeing today. To most people, the intriguing railroad development has been trailer freight, piggybacking. Our piggyback car fleet has changed rapidly from a few standard flat cars, each carrying a 35-foot van, to 85 and 89-foot giants designed for the service, each carrying two 40-footers. Not only do we haul our own trailers with lading picked up and delivered by our Union Pacific Motor Freight Company, we also move between major terminals, trailers, and piggyback flat cars owned or leased by the shipper. Just recently, we've started a service that could change transportation patterns across the country. We've begun piggybacking between principal terminals, trailers owned by truckers. Trailer freight has become an important piece of our business and will become more so with realistic regulations on rate making. Another advance in flat car philosophy is a V-shaped cradle laid down the center for better handling of coiled steel, such as that rolling out of Utah. Many roads own special types like those we've been talking about, but there's another car we have exclusively. 85-foot super cushion cars with Minuteman missiles are interchanged at Hillfield, Utah for movement between there and various launch sites. The birds themselves nest in their own air-conditioned trailers. Common now, covered hoppers still are special enough that many are assigned to specific services. Originated for cement, they offer easy unloading plus protection for other bulk commodities such as soda ash, phosphate fertilizer, alfalfa products, and clays. The latest in covered hoppers is equipped with a trough hatch that runs the length of the car. This is a feature that makes filling faster, easier, and more even. The covered hopper is another car that has undergone the enlarging treatment. Our new ones are 90-tonners. For bulk sugar and flour, which tend to compact in transit and become hard to empty, the air slide covered hopper is useful. It was devised to give gravity an assist. Looking inside this car, one sees what appears to be a conventionally arranged two-compartment hopper. Closer inspection reveals something different. A specially woven fabric lies between the lading and an air chamber near the outlet. To unload, low-pressure air is connected, and passing through the fabric, it virtually fluidizes the lading, which then flows out by gravity. A simple addition to an ordinary boxcar can make it a special car. Most of the soda ash from Wyoming is shipped in covered hoppers, but some consignees don't have conveyors for gravity unloading, so we supply boxcars to which roof hatches have been added. The consignee is happy with the shipper, and the shipper is happy with us. A car that is always in demand is the double-door boxcar. One Oregon plywood processing plant will take all we can furnish. The shipper likes the 15-foot opening that permits fast loading with forklift trucks. Of course, these cars are costlier, The wide doorways require stronger underframes and stouter side sheets. If piggybacking has caught the public's eye, the equipment that interests most shippers and keeps the Car Service Bureau busiest is a new style of boxcar. This is the car that shippers cry for. It's insulated, a big selling point, particularly with canners who may be shipping during the winter months. But the most important features are the cushioned draft gear to protect the lading from shock and the load restraining devices inside, which do this too, besides making loading and unloading much faster and cheaper by eliminating the need for dunnage. Interior and underframe improvements don't represent the last word in boxcars. Some have been heightened and stretched to the giant economy size with 10,000 cubic foot capacity, 2.5 times that of an ordinary car. The 86-foot high cube cars are designed with emphasis on interior space for such lading as bulky but relatively light automobile body parts. Some have as much as 40 feet of door space on each side. Also, for the efficient movement of auto parts is the new 60-foot boxcar, built for heavier loading than the high cube. It carries such components as transmissions and engines and special racks. 60-foot cars also are entering general service. The refrigerator car, once a special type, has become so again. The old ice bunker reefers are out when it comes to hauling frozen food. But we weren't frozen out of this traffic because Pacific Fruit Express came up with cars with self-contained refrigeration machinery. Except for once or twice daily inspection on the road, the diesel-powered refrigeration units are so reliable they can run for 3 weeks, even without refueling. PFE has taken the same idea and jumped into trailer freight with it. Temco vans offer the very best in piggyback door-to-door service. Just as with the mechanical reefers, we can preset the temperature in these vans anywhere from -10 to +70 degrees. We not only can keep frozen foods rock hard clear across the country, but also maintain just the right climate for meats, butter, and other perishables. Now, where do we get all these special and standard cars? We buy some and we build some. The Omaha Car Shop has a production line that can turn out several types of cars. From specialists in the business, we usually buy standard parts such as wheels, axles, truck frames, and so on. But we do make some parts ourselves. For example, spring plates for R40 reefers were turned out with a 15-ton press. A boxcar under construction really begins to look like something after the side assemblies are swung from a stockpile, then coaxed into position on the underframe. Once all the truck components have been put together, they are ready to be rolled to the waiting car body. Of course, every car we've built, bought, or rebuilt for a number of years now has roller-bearing axles. A salesman wouldn't run much risk putting his foot in this door, but in our trade, doors must operate, and since few of our customers hire weightlifters, we anticipate their requirements by being certain everything works. Our car department people provide some of the best assurance of safe, dependable operation by finding and repairing any defects a car may have before okaying it for service. When a car must be set out for repairs, muscles and minutes are saved whenever possible on the rip track. Men and machines team up to make the job easier and safer. On the road, one of the greatest time savers is the practice of roll-by inspection. Alert car inspectors not only preserve life and property, but have cut station delays often by as much as 85%. Not all mechanics are in the shops, roundhouses, or rip tracks. At busy terminals, some of them are equipped with motor cars or other vehicles fitted out with tools and materials needed to make running repairs. Car inspectors can quickly range a briefly stopped 100-car train for such routine maintenance as brake shoe replacement. Even with equipment-saving dynamic braking available with diesel locomotives, brake shoe renewal still is their major activity, particularly at Cheyenne, at the bottom of Sherman Hill. When the job is done, the other car men must be advised and the train cleared. Car inspectors now are wired for sound to save steps and get trains out of town sooner than we used to. Hot shots like the LAX, the SPF, and the AKC Northwest Forwarder run on fast schedules that are closely observed because on-time performance is the most important element of dependability. Just as one swallow doesn't make a summer, a train on a track doesn't make a railroad. A train can be only as efficient as the facilities that feed it and those who help get it over the road as fast as possible. There are silent sentinels, too, snuggling between their protective wedges alongside the rail in lonely country. They are out there to detect hot boxes. The trackside scanner picks up the heat that radiates from each journal of a speeding train. This is converted to an electrical signal and transmitted to a readout station where it appears as a spike figure on a graph. An overheated journal shows up as an abnormally high spike. Its position in the train can be located by the operator or dispatcher, who then can have the train stopped for inspection. One of the handiest things around a railroad is a place to sort out cars. Switching cars is a time-consuming chore, but at Pocatello and North Platte, retarder yards simplify the job. At North Platte, the busiest yard on the railroad, some wonder machines help make switching safe and efficient, easier. Here, incoming trains are broken up as they are shoved over a hump track. Then gravity takes over and the cuts roll down the leads to classification tracks for makeup as outbound trains. Referring to his marked consist, the hump foreman pre-selects tracks for a train being classified and directs the pin puller below where to make the cuts. As each cut of cars comes down the hump, its speed is picked up by radar, the same principle that trips up speeders on city streets. Every cut moves differently, governed by weight, wind resistance, and mechanical condition of the cars. The radar information is stored in a computer housed near the hump. The computer, knowing the track selected for the cut, in a flash correlates its speed, rollability, and distance from the next cars on that track to automatically set the pressure of the retarders so the cut of cars will roll to an easy coupling. The pneumatically operated retarders press their shoes against the wheels to slow the car if the computer says it moves too fast. The foreman's track selection already has been transferred and stored in an amazing mechanical memory bank in the computer building. It operates on a code system that uses the magnetic properties of 8 brass or steel marble-sized balls. The machine can store the switching movements for a whole train, directing the cuts left and right through the switches as varying sequences of the balls pass through it and activate its relays. At first glance, today's railroad might appear to be the same old-time, uncomplicated thing of tracks and boxcars. But beneath it, as under the roof of the computer house, pulses a current of advanced technology, of electronics and mechanics that is of space-age caliber. Nowhere so much as at a busy terminal like North Platte can one become aware of the 24-hour job that is railroading. Scenes like this are repeated throughout the world and impress us with the part railroads play in our lives as magnificent distributing machines that sustain the steady flow of things we need. Where operations are not as pressing, less expensive flat yards do the job well. In northeastern Oregon is our newest. Hinkle is a consolidation of 3 smaller yards made necessary when the building of new dams on the nearby Columbia River required us to move. Next to man himself, the major contribution to faster, safer operation has been centralized traffic control. From a single central panel such as the one at Nampa, switches and signals are operated electrically over a long stretch of track. It's possible with CTC on a single track line with long sidings to have two trains meet without stopping and safely pass. Recently, the dispatcher has been given a new tool for train control, direct radio contact with the crews. CTC is truly push-button railroading and a ready-made answer to anyone who says we're old-fashioned. With around 2,100 miles of CTC and 1,400 miles of double track, this is a highball railroad. Although we've been running a push-button railroad for years, there is always room for improvement. Our new CTC panel at Albina, which controls part of the track between Portland and Hinkle, is easy to use. A compact console of push buttons replaces the older spread of switch and signal levers. Not only modern facilities, but also good operating methods expedite our service. Blocking cars in a train is an example. By classifying cars in blocks according to destination, we're able to cut switching time along the way and do a faster job for our customers. Now, all these facilities and methods and equipment act directly to make us a good railroad. There also are some behind-the-scenes goings-on that are every bit as important. One vital activity in railroading is communications, moving information from one person to another. Good service depends on good communications, from hand signals to radar. We have a whole department devoted to handling the electronic and electrical means of conveying information. Our private telephone system alone, plus leased facilities, would serve a city the size of, say, Walla Walla or Fort Collins. And that's not counting long-distance lines. Just about the biggest thing these days is our microwave. This is super high-frequency radio. To spread the microwave net from Omaha to Portland and Los Angeles requires 77 repeater stations on high ground, such as that at Lonely Pilot Knob in Wyoming. Isolated and automatic, they are maintained by highly trained electronics technicians. Virtually weatherproof, microwave gives us the extra circuits we need for funneling information to the extensive computer center we maintain at Omaha, and for handling our direct distance dialing telephones and long distance telegraph. Most people would say a train runs on steel rails, but with shippers on one end, consignees at the other, and dozens of busy clerks in the middle, all filling out forms, you might say it runs on paper. The accounting people think so anyway, and they're right. My, how the paper mounts up. We seem to be setting a record at record keeping, but it's all necessary. Tunnels are being cut through the mountains of paper, however, with our electronic data processing machine. This is one of those remarkable electronic brains you hear about. It's housed in a big insulated room of its own in the headquarters building. Every day it digests thousands of bits of intelligence fed it from all over the railroad. It assimilates this information to return it in usable statistics and such practical documents as purchase vouchers and paychecks. Our people can make it do all sorts of otherwise tedious and time-consuming tasks. One is the never-ending preparation of traffic reports. All the information from the freight bills representing a 100-car train, say, can be reduced by a clerk to a small stack of punched cards, and the card data reduced by the machine to a foot-long piece of magnetic tape. From this snippet of tape, and thousands like it, the computer assembles the information and prints the traffic reports that give us the big picture of where our business is good and where it's poor. Computer people direct their sprawling electronic servant in other chores, such as speeding solutions to technical problems for the engineering and mechanical departments. Correctly programmed, the computer can come up in minutes with answers that once took hours of wearying arithmetic and slide rule work. For the stores department, it has been of great benefit in controlling inventories. By punched card, it keeps track of the thousands of parts and pieces it takes to run a railroad. Another huge job it does is to sort through a mass of data to furnish statistics for car record accounting. To us, a string of boxcars looks like a string of boxcars. But to some of the transportation department people, it looks entirely different. To them,
every boxcar becomes a punched data card to make easier the giant task of keeping tab on 155,000 cars a month and supplying our shippers with cars as needed. From yard offices all over the railroad goes information on each car and its contents and its movements. This data flows to the transceiver room at Omaha, where 4 times a day, every day, 15,000 of these cards are sorted into origin and destination territories. The information they contain is converted and teletyped as manifest and passing reports to the agents concerned. With these reports at their fingertips, our tracing clerks can give our customers positive information regarding their particular shipments. Information on the order of when we received the car from shipper or connecting line, when it has passed various terminals, and when it can be expected to reach the consignee. Provided with the exact location of his car, the customer also can arrange for it to be diverted to a different destination or to have it stopped along the way for partial unloading. A carload of freight doesn't begin with a freight-loaded car. It begins with a visit to some industrial traffic manager's office. All we have for sale is service. The success of our service is measured in car loads. The better the service, the easier and more often it's sold. But someone still has to sell it, our traffic agents. In a way, of course, we're all traffic agents, selling our service by the reputation we help build and maintain. The real selling we leave to the pros. They're the fellas we back up when they tell our customers what a good job we all do. Besides doing us a favor by bringing in the business, they serve the shipper, assisting him with his transportation problems, leaving with him useful reminders of Uncle Pete. Helpful as such sales aides are, they're no substitute for a sincere, personable salesman who knows his product, who may lose a carload now and then, but never a friend. We can put an awful strain on a friendship, though, with careless treatment. Battering a customer's merchandise by rough handling sort of shakes his faith in us. The fault's not always ours, though, and the freight claim department works closely with customers to educate their shipping crews and forestall improper loading. They pass along to shippers the results of their years of research in packaging and loading. A UP-designed tool given to shippers and their crews is the case loadometer. This handy device will show the best loading pattern for the greatest protection in transit. Once the pattern has been determined, stacking cases by the bonded block method is easily carried out. Cases are placed to make a stable, interlocked load. When it comes to producing properly loaded cars, the loss and damage prevention man is not really a magician. He's just another well-trained railroader, good at his job. To some, this may seem like playing with blocks, but it is serious business to the loss and damage prevention men who are helping reduce the needless waste and flow of claims paid for freight delivered piecemeal, dented, or otherwise damaged. Traffic agents and freight claim men aren't the only people on the railroad creating goodwill among our customers. About 1/4 of our freight business is hauling grains and fruits and vegetables and animals and meats. So we try to be helpful whenever we can to today's and tomorrow's farmers. Our agriculture department men are specialists in modern agriculture methods and crop development programs. They're traffic specialists too, and are always glad to share their knowledge. One look at today's track maintenance and renewal machinery should be enough to convince anyone who says we ought to modernize that this country's transportation problems are not caused by wooden axle, non-progressive railroads. The section gang still finds plenty of pick, shovel, lift, and pull work. But for big jobs, the engineering department has further modernized the section men with some ingenious machines that not only take much of the back brake out of gandy dancing, but also leave the track as near glass smooth as it can be made. Now, all this track and the trains and terminals and tools and techniques we've talked about, plus clerks and carmen and cashiers and mechanics and, of course, conductors, are Union Pacific. Each of us has his trademark. Call it character, personality, reputation, public image. Uncle Pete has an image to maintain. As a publicly owned corporation, UP is literally a person on paper,
with many of the civic obligations that you and I have. For some of us, our interest in the company doesn't end at the same time as our particular 8 hours or shift or job or trick or 150 miles. We discover company activity has followed us home. Our confidence in UP, maybe for reasons of personal gain, maybe as a kind of loyalty, extends to being part owners of the company by including UP stock in our personal investment and savings programs. Those of us who are stockholders get an annual report from management. Among other things, the report tells us about one of UP's main civic responsibilities, taxes. Being a railroad, we're hit pretty hard. $771 million in the past 10 years for income, retirement, unemployment insurance, and property taxes. UP taxes help build schools and parks, also airports, highways, and waterways for our competitors. Tax paying is but one of our civic duties. We do many things we don't have to. You and I chip into charities. Through the UP Foundation, the company makes cash gifts, not only to community chests and United Funds, but also to colleges and hospitals and cultural institutions. Through UP scholarships, we help promising agricultural students further their educations. With our free educational materials, pictures, literature, and movies, we're helping to tell the railroad story, as well as providing entertainment. Many youngsters have never been on a train, but they're fascinated with them all the same, and know a lot about them. With our gifts of old equipment, we're helping preserve the spirit and history of railroading. Dozens of retired UP steam engines are in city parks and museums, so all may wonder at the wondrous iron horse. Probably no piece of rolling stock we've donated ever was put to better use than one now at Griffith Park Travel Town at Los Angeles. What more exciting place could there be for a child to have a birthday party than a retired railroad dining car reserved for her and her friends? We gave it to her and to all the other youngsters of the city.
We can do these things because we're a profitable business. As profitable as we can be with old-fashioned regulations and discriminatory taxation. We'd like to make more money.
Who wouldn't?
And that's no sin. We do as well as we do because of the facilities and equipment and methods and people we have for giving the best service. As long as all of us do this for our customers and our communities, we're going to stay in business. Does that answer your questions?
All but one.
What's that?
How did you ever get to know so much about this railroad?
Well, Tom, you stay in this racket as long as I have, and you'll learn a few things, too. Of course, it helps if you've seen the new company movie.